Okay, here's how we're doing problem number one. It says the graph is down here, it's 1-to-1 or on, let's see here, let's move that up a little bit so we can really see that. 1-to-1 or not 1-to-1. 1-to-1 would be when you could draw a horizontal line and it would only cross in one place. Why is that? Because if it crosses in two places like this one's doing, there are two different x values that have that same y value. It's not 1-to-1. Okay, so not 1-to-1. And then it is continuous because you can graph it, without lifting your pencil. So continuous. I'm not going to be able to fit the whole thing on there. And then option 3 is not linear, okay, because it has curves to it, right? It goes up and comes back down and all that kind of stuff. Linear is going to be just a straight line, either increasing or decreasing the whole time. So not linear, non-linear. The graph has two x-intercepts here, this one and this one. So multiple x-intercepts. So multiple is right here, multiple. And one y-intercept. So one y-intercept. The graph is, oh geez, here we got to look down there and see what it says. The graph is symmetric. It's not symmetric because I couldn't draw, the y-axis is not a line of symmetry, and you couldn't rotate it about the origin and it land right back on top of itself. So not symmetric right there. Okay. And then let's see, what's the next one here? The graph has, shoot, this is awkward having to scroll down there. The graph has, okay, so it has, it has a relative maximum right up here, right? And then it looks like it comes down, goes flat, and then keeps on going down. So it only has a relative maximum. It doesn't have a minimum. So I'm going to say maximum right here. Okay, so maximum. And that's this spot right there is the maximum, right? I know it looks like maybe something's going on here, but I think it just flattens out and then goes back down. To be a maximum, it's got to go from increasing to decreasing, or to be a minimum, it's got to go from decreasing to back to increasing. But here it just keeps on going down. Okay, that's another reason why there's only a maximum. And then the end behavior, I'm glad I can see that right there. So the end behavior, as we're going down here, as we're going to the left, we're going down. So this should be negative infinity right here. And as we're going to the right, we're going down. So that should be negative infinity over there. All right, next problem is number 2. Oh boy, the graph is 1-to-1. Yes, this one is 1-to-1. 1-to-1. Because I can draw a horizontal line anywhere. It only crosses in one spot. Okay, I know that part right there might make us nervous because it does look like it's kind of flattening out, but it doesn't go completely flat for more than one point. So 1-to-1, it is continuous and nonlinear. It doesn't make just a straight line. It's got some curve to it. The graph has, let's see, how many, what is it looking for? X-intercepts. Only has one x-intercept because it's right there. There's our x-intercept. It has one y-intercept, if that's one of the options here. Let's see if we can zoom out here. Yes, one y-intercept. So it should be 1 right here. Okay. And then let's see what else does it have. The graph has, I'm on blank 6 here. No lines of symmetry, no point symmetry. There's no symmetry to it. Well, let me take that back. It has point symmetry, okay, right there, because if I rotated about that point right there, 180 degrees, this would come down here and this would come up there. So it does have point symmetry. So on blank 6, we want point symmetry, okay? And then let's see, the graph has a no extrema, because it's constantly increasing the whole time. It just keeps increasing. And then The end behavior. So Y goes down on the left. Oh, they tricked us here. They're going to the right first. Woo, man, that's tricky. It's going up. I hope you didn't get tricked by that. And then over here, it's going down. It's going to the left. So they do the left second, right? Usually the left is the one that we study first. So as we go to the left, it's going down. So negative infinity over here on this line. I bet that got some people. Let's go to the next one. This is definitely a discrete. The graph is discrete. Oh, wait. First, we got to do this. It's 1 to 1. Okay. 1 to 1. 1 to 1. And it is discrete because it's just a bunch of points. Discrete. And it's, well, is it linear? Yeah, I mean, the points are following a linear pattern. You're not connecting them. Usually when we say linear, we're connecting them here. So this one could go either way, but I'm going to go linear on it. The book might say nonlinear because it's not connected and continuous. Linear functions are continuous. The graph has, let's see, one x-intercept. Here it is right here. And it has one y-intercept. There it is right there. And one y-intercept. The graph is symmetric. Is it symmetric about anything? Well, it's not symmetric with a line. So I would say no, not symmetric. Let's do not symmetric. And the graph has no extrema and no relative extrema. And then, well, ooh, oy. I guess it does have this point right here. If this doesn't continue to go on, does it say that it continues to go on? So that would be a minimum right there. And this would be a maximum up here. Oh man, this is tricky. I wish I wouldn't have assigned this one. So that might be 1 right here, 1 extrema. That's blank 7. But it doesn't let you, I guess it would be two extrema because there's a minimum and a maximum and one relative. Jeez, I'm going to stick with my 0 and 0. This is a very tricky question. I'm going to say 0 and 0 is the right answer. I could be wrong on that. As we go out to the right, the function is going up unless it stops. So, man, is no end behavior one of the options? I should have looked this one over before I signed it. Oh, good. Okay, so it's not like no end behavior. But as we go to the right, it's going up. So, okay, that makes more sense. And since they're claiming that it keeps on going, then there is no extrema. And if we go to the left here, it's going down. So that's negative infinity over there. Okay, that clears it up once we see blank 9 and 10, right? Whew, because the dots just keep on going. It doesn't stop right there, right? So that means that it's going down to negative infinity, up to positive infinity. All right, next problem. Let's move on. Okay, the graph is continuous because I can graph it without lifting my pencil. Boom, right? So continuous, and it's nonlinear because it's got curve to it. Nonlinear. The y-intercept represents 50 milligrams of iodine at time 0. So represents, let's see, what are their options down here? It is initial amount of iodine, okay? So initial amount of iodine. Initial amount. I got to get my pen working here. The y-intercept represents initial amount. Okay. Let's see. Blank 4. The graph is, oh man, it's so awkward. Symmetric? Is it symmetric about the origin? No. Is it symmetric about the y-axis? No. No symmetry. So not symmetric to anything. So not symmetric there. And then end behavior implies that as time increases the concentration of iodine, well, what do you think would happen to the concentration of iodine? Wouldn't it just keep on going down until it got, like pretty much close to 0, right? So that's the idea there. So it's approaching 0, decreases to 0, right? That's that one right there. Continues to decrease to 0. Next one. Man, this is taking longer than I thought. Use the key features of the graph to sketch it. Well, we got an x-intercept at 5, 0. That does not have an x-intercept at 5, 0. 1, 2, 3, 4. That does not have an x-intercept at 5, 0. This is on the next page, my other options. Let's see if there's one with 5, 0. There it is. There it is. So we're down to two choices, right? Okay, let's go back and see what other choices they can narrow it down for us. 0, 2 is the y-intercept. Well, that's negative. So it's got to be this one because there's 0, 2 right there. Let me write on it. I always feel better when I'm writing on it. 0, 2, and this is 5, 0. Well, I don't need to read the rest of the problem. It's got to be this last one right here on problem number 5. Here comes problem number 6. Oh, yeah. So we didn't talk about this yesterday. I'm just curious how many of you know how to graph a line in slope. Slope is 4, and the y-intercept's negative 15. So slope, that's what M stands for, is the slope. That is equal to 4, and the y-intercept is equal to negative 15. So, well, that's not going through negative 15. That's not going through negative 15. So on the next page, is there one going through negative 15? Well, that one stands a chance of going through negative 15. This one, no way. So this is the only right answer. But I do want to talk about the slope for a second. See, the slope is 4. So I think a lot of you guys remember that slope is rise over run. So is it going up 4 over 1? Yes. I mean, this is hard to tell because the scale here is counting by 2's over here, and it's counting by, it's counting by 2's here as well. Man, this is hard to tell. It's not going right through any of the, where the lines intersect there, grid points. So, man, it is really hard to use the slope to figure that out. But it does. I mean, this is definitely a positive slope. So, I mean, this is definitely the right answer, the third one right there. Okay. So let me circle it. Okay. This is definitely the right answer because it's going through negative 15. It's the only one going through the right y-intercept, right? The y-intercept's negative 15. That's that number right there. Hey, I hope you did well on that little mid-chapter check. I know you might feel like this problem's unfair because we didn't talk about slope-intercept form, but I think a lot of you guys know that from prior classes. Okay. Thanks for watching.